Okay, so here's the moose question. Very quintessential life science calc question. I have no idea why, but the book loves moose. All right, so the age of a captive female moose and its mass can be described by the function M of t equals 369 times 0.93 to the t times t to the 0.36, where t is between 0 and 12. Okay, so this just says that time is between 0 and 12. I guess that means the average lifespan of a moose is 12 years old. I don't know if that's real. I would imagine that it is. So this just says like an old moose is 12 years old. Where M of t is the mass of the moose in kilograms and t is the age of the moose in year. So find the age at which the mass of the female moose is maximized. What is that maximum mass? Okay. So what is the maximum? That is an algebra question, but we need calculus to get there, right? Because to find C, to find the max, we need, oops, excuse me, we need the derivative, right? We need to find where this is 0 and what location of T is that. Once we find T, we can just bloop, pop that into the equation. So I know you're going to love this derivative because it's not as easy as the other ones, because notice this is a product rule with an exponential, with an exponential and a power rule. Here's the coefficient. Okay, remember, the first step is find m prime of t. The second is to set the derivative equal to 0. The third is to solve, and then 4 is the sign chart. All right, away we go. Let's see. Oh, it's kind of big. Ooh. Okay, let's see. Do I want to start here? Yeah, here's good. Okay. I just need to remind myself to write small. Okay, so this is the product rule. We'll say here's F, here's G. Remember the derivative of F G prime is F prime G plus G prime F. So M prime of T. So the derivative of F prime, the coefficient is along for the ride. Times, remember the derivative of an exponential is a copy paste job, times the natural log of the base, 0.93, and then technically times the derivative of the exponent, but the derivative of the exponent is just 1, so we don't need it. And then times g, so that's just t raised to the 0.36, excuse me, plus g prime. This is just plain old power rule, so it's 0.36 t to the negative, what, 0.64, if I can subtract in my head, times just plain old f. That's 369 times 0.93 to the t. Okay, and I would recommend leaving it like this. All right, don't try to factor it out. Just don't get fancy on me. We're going to set it equal to 0. I'm going to write it slightly cleaner. No, this is when I'll start taking stuff out. All right, so common terms to both. Both terms have a 369, so we're going to take that out. Both terms have the exponential of 0.93 to the t. So we're going to factor those things out. Okay. Yeah. Sorry, just want to make sure. Yes. Yeah, okay, sorry. I'm just trying to decide which is the best. So 369, 0.93 to the t times the natural log of 0.93 t to the 0.36 plus 0.36 t to the negative 0.64. Now I'm just going to rewrite this portion. So 369, 0.93 to the t times the natural log of 0.93 t to the 0.36. So that's 0.36 over t to the 0.64, right? Because the negative exponential tells us to put it in the denominator. Remember, eventually we're solving for t, right? Eventually we are solving this thing for t. What we want to do is we want to get a common denominator because I don't want this term to have a not fraction and this term be a fraction. So what we're going to do is we're going to multiply in by our special form of 1, which is t to the 0.64 over t to the 0.64, right? Because I want that denominator. So 0 equals 369 times 0.93 to the t times the natural log of 0.93 times, now bear with me, t to the 0.36 times t to the 0.64. When the exponentials are multiplied, recall that when the bases are multiplied, the exponents are added. So 0.36 plus 0.64 is actually 1. So this turns out to be the natural log of 0.93 times t to the first, and then plus 0.36 all over t to 0.64. Oh boy, oh boy, oh boy. Okay, so we're going to keep solving, but lucky for us, since we have term times a term, we can split them off into their own. So 0 times 369 times 0.93 to the t, and 0 equals the natural log, I'm going to say t times the natural log of 0.93 plus 0.36 all over t to the 0.64. Well, over here on the left, although it looks like the gnarliest, it's d and e, right? Exponentials by definition never equal 0. Right? They have a horizontal asymptote, right? So we don't actually have to worry about this one. You wipe the sweat off your brow. Thank goodness. So what we're going to do now is solve this one right here. But we still want to bear in mind the denominator. Okay, so we want the numerator and denominator because even if it is going to be undefined, it's still kind of like a point of interest. That makes sense. So we just look here at the numerator, 0 equals t times the natural log of 0.93 plus 0.36. We're just going to subtract that over. Negative 0.36 equals t times the natural log of 0.93. So we're just going to divide by that natural log. So negative 0.36 divided by the natural log of 0.93 equals t. I'm going to grab my handy dandy calculator right here. Sorry, scooch, scooch, scooch. 0.36 divided by the natural log of 0.93 is, oh, hello. I was like negative, it can't be negative. I need negative, right? I need my negative 0.36. See, this is why I need y'all here. Natural log of 0.93. Now we're in business. He is approximately 4.96, maybe 5 years old. Okay, about 5 years old is the mass of is the maximum mass. And we do have a potential one of looking at the denominator looking at the denominator now. 0 equals t raised to the 0.64. So here that's just Again, 0, but if the moose was just born, it's not going to be its maximum. So we don't really need to pay attention to it, right? It was just born. It's obviously not at its heaviest point in its life. So just to double check, this is the only number we got. So it should be the max, but we always need to double check. If I have 4.96 x f prime of x, and then f of x, let's say I put in, again, 10. I like 10 if I can do it. Okay, and then maybe 1 over here. If I pop in 10 to any version of the, what am I trying to say? Not denominator, hello. Derivative, that's the D word I'm looking for. Okay, if I pop in 10, that's going to be a positive plus a positive over a assuming 10. What is 10 times, what is the natural log of 0.93? I think it's negative. Yeah, that's negative. Okay, so that's going to be a negative plus a positive divided, a small positive, right? 0.3 divided by a positive. So that's an overall negative. We're going to be decreasing. So then if I pop in 1, well, notice this number plus 0.36 is a positive, divided by 1 is a positive. So we are increasing. So yes, it truly is the max. Okay. So or the moose, not me, the moose is at its max at 4.96 years old. Okay. So to answer the question, what is that max? We just pop in the 4.96 into M. So 369 times 0.93 to the 4.96 times 4.96 to the 0.36. Lucky for you, I've already done that. That is 458.22 kilograms. Okay, so pretty heavy moose. Okay, pretty heavy moose. Because what? A kilogram weighs more than a pound, right? Is it 2.2? 2.2 pounds is 1 kilogram? Okay, a lot of work, right? This seemed technical. Just remember to take it piece by piece, factor things out. Generally speaking, your exponential term, this step out here, is going to eventually disappear. So just bear with it. Eventually, half of it just goes away. So just be kind to yourself and recognize that I just got to get through this mud so I can clear things up. But that's where we'll stop today. We'll pick up with page 5 and move into 5.3 actually when we meet next. You'll have an awesome, awesome day, and I will see you next time.